All right, so question number 5 from the review. Given the function q of x is equal to negative 2x squared plus 12x minus 10 over x squared minus 8x plus 15, determine its domain, vertical asymptotes, horizontal asymptotes, holes, x-intercepts, and y-intercepts. Then graph the function. If it doesn't have one of these, then omit it. All right, so the first thing you're going to want to do is determine the domain. To do that, we're going to take the function and we're going to factor. We're going to factor the top and the bottom. So I'm going to rewrite the function q of x. So I'll write q of x equals, and we're just going to factor. So I'm going to pull out the negative 2. I'll do that up here so I can write it down a little bit nicer. So we got 2 and then x squared plus, oh sorry, not plus, x squared minus 6x plus 5. So we're going to factor out like that. And then we're going to factor this trinomial, and that's going to be negative 2, the GCF, and then we'll factor 5 to be x minus 5 and x minus 1. So we've got x minus 5 and x minus 1 over, and then now we're going to factor the denominator, 15, 5 and 3. 5 and 3 gives us 8. If we have x minus 5 and x minus 3. All right, so notice that you can cancel these guys. Don't cancel them yet. Identify your domain. So what we want to do now is we want to state the domain. So our domain is essentially the members of x such that x does not equal 5 or 3. So 5 or 3. So we don't want 5 or 3. You don't have to write it in set of notation for the test. You don't have to write it like that. You can just say not 5, not 3, and then I'll assume it's everything else other than those two guys. Second part, once you've done that, you can cancel. So we're going to cancel these guys out right there, the x minus 5. And in class, we said that that indicates that we have a hole. So we now know that we have a hole. At x equals 5. So we know we have a hole at x equals 5, and we need to figure out what that hole is. So what I'm going to do is I'm going to restate my function. My function being q of x, and this is called simplifying the function. So we're going to simplify the function. Q of x equals negative 2 times x minus 1 over x minus 3. So we got x minus 3, and then comma. Since you have a domain member being eliminated, we're going to say it cannot be 5. So 5 can't happen. So what we want to do is we want to figure out what happens if we were to plug in 5. So what we're going to do now is we're going to find the hole. So we're going to say q of 5. So we're going to plug 5 in, and we're going to get negative 2 times 5 minus 1, which is 4, over 5 minus 3, which is 2. And then we simplify this, and we get negative 4. So we have a hole at x equals 5, which now has an ordered pair of 5, comma, negative 4. So that's the first part of the problem. Second part of the problem is you probably want to identify the horizontal asymptotes and the vertical asymptotes. The vertical asymptote is pretty straightforward. It's now based off of this denominator right here. So we have a vertical asymptote. So we're going to say we have a vertical asymptote located at x equals 3. That's the vertical asymptote. Now we're going to find horizontal asymptotes if they exist. The horizontal asymptote is when the lead coefficient, so we can kind of ignore that and ignore that. So the lead coefficient, which is negative 2 over 1, which gives me negative 2. I guess I could leave it scribbled out because we don't need it anymore because we now have the simplified function right here, which is much better to look at, much easier to look at. So we could just say negative 2 over 1. So our horizontal asymptote is going to be at y equals negative 2. Next, x-intercepts and y-intercepts. X-intercept is when you set the function equal to 0, or you can set just the top equal to 0. I'll do the whole thing. So we'll do the x-intercept. So the x-intercept, I guess the shortcut would just be when the top to negative 2 times x minus 1 is equal to 0. The negative 2 is going to cancel out, and we get x minus 1 equals 0, which means x equals 1. So our x-intercept is going to be at 1, comma 0. Next, the y-intercept. So the y-intercept is when you plug 0 into the function. So what we're going to do is we're going to plug 0 into the function, and we're going to get negative 2 times 0 minus 1 over 0 minus 3. And that's going to come out to 2, negative 2/3. So our y-intercept is going to be located at 0, comma, negative 2/3. So we've got our vertical asymptotes, our horizontal asymptotes, our x-intercept, our y-intercept, and our hole located at that point right there. Next step is to set up a t-chart. This is just to get some points so we get a better accurate, a more accurate, not better accurate, sorry, a more accurate function, a more accurate graph. So we have x and f of x. I always like to put in my domain restriction, so 5 and 3. So I'll put 3, I'll put 3 here. So we'll place 3 right there. And then we'll place 5 over here. All right. So 3 was our vertical asymptote. So above it, I'll put vertical asymptote, which means this guy is undefined. So I'll write undefined. And then 5, that stood for our hole. So we can write hole over that. And we actually know what that is. It's going to be at 5, -4. So I'll put a -4 in there. So 5, -4. And then now we just need to pick some points. But before I do that, I kind of also want to put in our horizontal asymptote. So the horizontal asymptote just means that as you approach -infinity, we're going to approach -2. So as you approach -infinity, you're going to approach -2. And also as you approach infinity, you're going to approach 2. So that's a good thing to understand. Sorry, -2. That's a good thing to understand as far as the horizontal asymptotes are concerned. Next, put the x-intercepts in there. The x-intercept is at 1, 0. So I'll put 1, 0 right there, I guess. And then -0, -2/3, which would be right here. So 0, -2/3. Now for graphing purposes, 0.7, that's probably going to be okay. And then now pick some points to plug in between your vertical asymptotes, your holes, and your other regions you don't have. So I'll plug in 4. So I'll take 4, plug in 4, and I'll plug it into this function here. So when I plug in 4 here, I'll get 4 minus 1, which is 3, which is -6 over 1. So I'll get -6 over here. And then I'll plug in 6. Not because this is -6, but because it's the number after 5. So when I plug in 6, we'll get 6 minus 1, which is 5, and 6 minus 3, which is 3. So we'll get -10 over 3. So -10/3. And if you want to simplify that, that comes out to -3.3. Next, we're going to graph these points here. So we set up our vertical asymptotes and our horizontal asymptotes. The vertical asymptote we have at 3. So I'm going to go over 3 spaces and draw a vertical asymptote. So let me go down on the -3. And then we have a horizontal asymptote at -2. So I'll graph that guy horizontally at -2. All right, so that's the first thing I'm going to do when I start graphing is get my horizontal and vertical asymptotes taken care of. Next, I want to start plotting some of these points here. So I'm going to start with the 0.7. So -0.7. So we go 0 and then down to 0.7, -0.7, which gives me a point right there. Next, 1, 0, which is this point. And then we have our asymptote. Now, based off of these 2 points right here, I'm going to say that my graph is going to go up like that. So it's going to follow the asymptote, and then it's going to do the same thing over here. Now it can't go back up because it doesn't have any other x-intercepts. It only has that x-intercept. And then I'm going to graph 4, -6. So go over to 4, and then go down 6 spaces, 2, 4, 6. I got that point right there. And then I want to graph 5, -4. But 5, -4 is our hole, so we have to be careful when we graph that guy. Go over 5, down 4. Instead of putting a dot, or actually, well, that's right, put a hole right there. So 5, -4 has got a hole. And then graph 6, -3.3. So 6 and then -3.3, which is roughly there. Connecting those 3 points, but when I connect it, make sure I don't go through the hole. So I'm going to have a point that looks like that. And then I'll have a graph that looks like that. So I've got my domain. The domain is stated right here. I've got my vertical asymptote right there, my horizontal asymptote right there, my x-intercepts right there, only one of them, my y-intercept right there, the graph, which is right here, and the hole located right here.